I think that's a great question. Okay, so a summary of some of these different groups is to think about how we can evaluate this structurally. And I don't know if I have enough room to do this, but we'll see if we can squeeze things in. So this idea of activating, deactivating, and ortho-para groups versus meta additions, all relative to benzene. So we can think about some groups then that, like toluene, actually, I'm going to erase this. Let's just put like a big line here. So we could imagine something like toluene here, and why don't we use green? So this is a weak activator. And now the activating groups are groups that have lone pairs of electrons on the atom that's connected to the ring. I'm just going to put it on the top here. So something like an ester, or something like a hydroxyl. Actually, sorry, first let's put in the methyl group here. So we'll make it simpler. So CH3, or a hydroxyl, or an, looks like that benzene gets stepped on, or an amino group here. And all of these groups are moderate activators. So Eva, I'll scroll up in just a second here, since I'm on a roll, hopefully with this summary, and then we'll go back up for a second. So then here, these are moderate activators. And now let's start thinking about the deactivators. And then when I finish this one too, we'll talk about the lone pair. So now relative to benzene here, we have things that are weak deactivators. So this could be the halogens. Okay? So this is why don't we use a different color? Red maybe? Weak deactivator. And now we have groups that are moderate deactivators, and these are going to be functional groups that have an electron withdrawing group connected to the benzene ring, but they do not have a lone pair of electrons, so they cannot donate electron density into the ring. So something like a ketone, an amide. There's not enough room here, so I'm going to clump a bunch of them up here. A nitrile. These are all our carboxylic acid derivatives. This weird-looking benzene with an ester, or a carboxylic acid. So these are all going to be groups now that are moderate deactivators. And then last, we have a couple more here. How about groups that have a really strong dipole, that are just pulling electron density away from the ring? Something like nitrile, something like SO3H, something like a trifluoromethyl group, CF3. So these are all going to be strong deactivators. So now that overall here, we're going to have a couple of different scenarios. So then for Diana, the ester and the group between the ester and the alcohol. Oh, it's this one. This is a botched ether here. So let's go. OCH3. Okay. So notice here, everything is related to benzene. Yep, you're welcome. And then I'll come back to the questions that we have here in a second. And what we can think about is that relative to benzene, so these groups here, these are all activators. Oh, I don't know what happened. Okay. These groups here on this side, these are all deactivators. Not sure about this color scheme. And then I guess we can use one more color here. But then what you'll notice is that these groups, including the halogens, these are orthopara directors. How about another color? We haven't used this orange. How about green? Oh, we have green. How about orange? And these groups are meta directors. So a couple of things to put this into perspective, and then to the questions. And I don't expect us to memorize necessarily strong so much versus moderate, or we don't have to parse out over here on the right side which one is more moderate. But the key thing is, so for activators and orthopara directors, notice they can either be weak and have an alkyl group attached to the benzene ring, or they have a functional group that has lone pairs. And I think this was your question, Hannah, perhaps, is that all of these groups here have a lone pair of, at least one lone pair of electrons, two lone pairs, one lone pair of electrons that can be donated into the ring to help in resonance stabilization of the carbocation intermediate. And it'll participate directly in resonance stabilization when a group is added at the ortho or the para. You do not have that in all of these deactivating groups, which are all these other meta directors. We'll ignore the halogens for a second. All of these have groups that are electron withdrawing, whether it be a carbonyl group and all its derivatives, or something strong like nitro or trifluoromethyl. But these groups do not have an atom that has a lone pair of electrons directly connected to the benzene ring. And a really good example of this, I think, is the ester. So considering over here on the right, this ester, here with the oxygen directly connected to the ring, it can participate in resonance stabilization. And it's an activator and an orthopara director. If you flip this ester around, meaning move the oxygen over onto this side, you now have this compound in a center, kind of in the top left center here, and trying to circle. Notice it's still an ester, but the oxygen is no longer connected to the ring. Now it's a meta director and a deactivating group, because it's now only pulling electron density away from the ring. And it does not have any group directly connected to the ring with a lone pair of electrons. Okay? So a lot of different groups, all relative to benzene. Activators are orthopara directors, with the exception that the halogens are actually deactivators, but orthopara directors for the reasons we talked about. All of these groups are deactivating. They're pulling electron density away from the ring, and they're helping make a bad situation the least bad in terms of resonance stabilization, which is why the group ends up at the meta position. All right. So I'll post this when we're all done, but hopefully that helps summarize a lot of these different groups. And I'll hopefully, let's see, I'll make it a little smaller. You can still see and scroll up. Eva, does that help, or do you want to go back further? I'll make it smaller. That's good. All right, excellent. Okay, so any more questions about the summary that we have here? And this is essentially what was on those slides, I think, but I just was trying to show off all the colors that we have. Okay, so then a couple more aspects of these reactions, and these are some of the things that we'd seen